Good morning, this is your Stat Sensei, Mr. Spensei, and this is a warm-up for reading computer printouts. So a random sample of 16 used Ford F-150 Super Crew 4x4s from Autotrader.com was selected to determine whether the number of miles driven could be used to predict the used sales price. So I want to mark a couple things here. Number of miles driven. All right, so our number of miles driven, they want to use that to predict the used sale price. So in this case, used sale price is our Y or our response variable, and number of miles driven, that is our X or explanatory. All right, real important to know that because that's going to help us out. So let's go ahead and look for the most important word. The most important word in the printout is the word constant. And by now we should know that that is our y-intercept line. All right, so that is our y-intercept line. And directly below it, wherever it shows up every time, is our slope line. So here we have our slope line. So our first question is asking about the explanatory variable. Well, actually, we identified it up here as miles, but look, it's actually given to us here. And remember, explanatory, that's just like saying our X. So this is our X variable, which happens to be miles. The next thing it asks for is our y-intercept. All right. And so obviously y-intercept is going to be on the y-intercept row, and it happens to be the very first number that shows up, which happens to be B, which in this case is 38,257.13. All right. Next thing it asks for is our slope. And of course, slope is going to be on the slope row, and it's directly below the y-intercept. And we actually have, in this case, a negative slope. We have a negative 0.1629 slope. Next thing it asks for is standard error of the slope. Well, the key word is here is slope. So we know we're going to be on the slope row. And looking on the slope row, there's standard error. Sometimes it says standard deviation, but standard error. So it's going to be our standard error is 0.0309. The next thing it asks for is our regression equation. All right, we're going to write it up here two different ways. I'm going to write it the way that's technically acceptable, and then I'm going to write it where we define the variables. So y hat equals, and we always go the constant first. So 38,257. And since I don't have room, I'm going to leave off the point. No, I'll include the 0.13 minus 0.1629x. Okay. Now, to eliminate defining the variables, we can write it this way. Well, we know our response variable is sales price. So we'll put sales price with a hat equals 38,257.13. That's our y-intercept minus 0.1629. And we need our x variable, which we said up here and right here was miles. All right, so real quickly, that's our y-intercept. And this right here is our slope. Okay. The next thing it asks for is that t-statistic for the slope, and the one below it says the p-value for the slope. So we know we're looking on the slope row, and the t-statistic for the slope happens to be the negative 5.62, negative 5.268, 2628, and the p-value is 0.00012. All right. The next thing it asks for is our coefficient of determination. Of course, we don't see that, but not by now we should know the coefficient of determination is our r squared. So I need to look for r squared. Well, I have two of them, and we expect there to be two of them. And we never in this class will use the r squared adjusted. We're just going to use this one, which happens to be 66.42%. All right, then we're looking for correlation coefficient. Now, correlation coefficient, I can look around and I won't find it, but I do have the information. The first thing I need is the sine of the slope. So let's look for the sine of the slope. Well, in this case, the sine of our slope, our slope right here happens to have a negative, so this is going to be a negative correlation coefficient. And we also need the square root of r squared. Now, we need to turn that r squared into a decimal. So we're going to take the square root of 66.42. So 66.42, I'm dividing it by 100. So now it's a decimal, and I'm going to take the square root. There's a couple ways to do it. I like to raise it to the half power. Raise to the half power is 0.8149. So negative 0.8419. So sine of the slope and square root of r squared. Alternatively, you could have pressed the blue button and then the square root sign and put in the 0.6642, and you still get the same thing, but have to make it negative by taking the sine of the slope. The next thing it asks for is the standard deviation of the residuals. Okay, so that's our S. This is our standard deviation of the residuals, which in this case is 5,740.13. Now, I'm going to go off on a limb right here, and we're going to talk about something. All right, if I look at the residual line, first off, let's take the square root of that 329,49107.7. And let's take the square root of that. And look what I get. I end up getting 5,714.3. So the square root of this number equals S. All right? And if you just hold off just a second, I want to verify something. And one other thing, if I take this number and divide it by 14, watch what happens. 46,000 or 46,128,7508.7, and I divide it by 14, I get this number. So this divided by the 14, which is our degrees of freedom, equals that. And that's just a little bit of extra information, not so important for this class, but I did want to point it out to you. All right, appreciate you watching. Look forward to seeing you on the next one. Thank you.